For 6.3, simplified form for radicals, there's just a couple concepts to learn about it's all about getting rid of that symbol, of the root symbol. We want to get rid of it. Property 1 says whatever root it is, it's applied to everything inside, so you can treat them individually. You can break this apart. And property 2, if it's a fraction, then the radical basically pertains to both of them individually. You can split those. It'll make more sense when we get into it. Again, I'll show you my notes. I just kind of hold them up and you can pause it if you need to. Here's the most common cubes that you'll want to know. The two most common are 8 and 27. 2 cubed is 8, 3 cubed is 27. Those come up over and over. 64 a little, 125 sometimes, but these are the two biggies. When you see these, well, and 1, I guess I should have put 1 in there, but 2 cubed is 8, 3 cubed is 27. Those are the ones you see the most. So here's my hint. I prefer to think, okay, break it down into perfect squares. 16 is a perfect square. There's a square root of 4. So x squared, I can pull one of those out. Y squared, I can pull one of those out. So you think anytime that you see something squared, you pull one of them out. Okay, so rationalizing the denominator is the biggest concept in this section. It's simple until you get one that's not a perfect square. Here, square root of 4, again, you break this apart using the second property. Square root of 4 is a perfect square. So you don't have to do anything to rationalize the denominator. All you do is take the square root. However, when you get a denominator that is not a perfect square, like 6, then you have to think, okay, what do I multiply it by to get the perfect square? Well, when it's a square, or to get the whole number out, when it's a square, you literally multiply it by itself. Anytime it's square root, multiply by itself. So square root of 6, I just multiply by square root of 6 and I get 6. Square root of 6 times 6 is 36. Square root of 36 is 6. So what you do is you multiply the numerator by the same thing. Now, where it gets tricky is when you don't have a square. We're talking a cube root here. There is no perfect cube of 4. When there's a square root, it doesn't matter. You just multiply by the same thing and you get that number out. When it's a cube root, you have to think, and I say must multiply by something that will give us a perfect cube. You want to think, what does 4 divide into that's a perfect cube? Or what can I multiply 4 by to get a perfect cube? And you want the lowest, smallest perfect cube you can get. And then I gave this little rule here, but what we want to think is cubed root of 4. What's the closest thing 4 goes into that's a perfect cube? Well, it's 8. 8 is a perfect cube. I know 4 times 2 is 8. I multiply by what's missing, what will make it a perfect cube. I am going to make a perfect cube out of 4. I do so by multiplying by cube root of 2. If that's a 5, you make that a 5. If it's a 4, a 4. The same root you can multiply together and combine the terms. So cube root of 4. I know there is a cube root of 8. I make 4 8 by multiplying by 2. So cube root of 4 times cube root of 2 is cube root of 8. So I do that to the top. The top is just done. You just stick it in there. 7 times the cube root of 2. The bottom, we now have a whole number. The cube root of 8 is 2. So that's how we rationalize the denominator. Here again, we had a square root in example 10. So all you do is break everything apart, multiply by the square root of 5z. That'll give you your 5z, but you do it to the top as well. Square root of a perfect square. Here's some rules you can look at. And then some examples on the back here. Square root of x squared means absolute value of x, because on x squared, it can be 1 or -1, and it's going to be 1 regardless. Cubed root, square root of cubed root of x cubed. Well, now you got absolute value because you're talking about a -1 or a 1. Okay. And there, here's the little rule. N to the a of n, absolute value if n is even, n to the, or cube root of a to the n, and n root of a to the n equals a if n is odd. So if it's odd, it's just whatever a is, because if it's a negative, it's going to be a negative. If it's even, then we have to say it's absolute value. Okay. Let me just work a couple of these that will be similar to what you'll see on the test. Number 21, square root of 18 cubed. So for square root, you want to think squares, think perfect squares. So you think perfect squares by thinking, well, 4 is a perfect square, 16 is a perfect square. Oh, shoot, I shouldn't have skipped one. 4 is a perfect square, 9, 16, 25, so on and so forth. So you can break this down, and you got 18. You just look and say, does one of these go into it? Well, it sure does. 9. Square root of 9 times 2 times, and I'll expand this all the way right now, but you don't have to. This is the factor that we're looking for. We have 9 times 2. I know that the square root of 9 is 3. Well, I'll wait. I'll write it off. Square root of 9 is 3. And then what happens here is every time I have 2 of something, I pull 1 out. I have 2 of those, so I pull out an x. Now I'm left with a 2 and an x. There's no square root of 2, and there's no square root of x. So that's my answer. You can always think, okay, it's 9 times 2, and then I can pull an x squared out of x cubed, and I have x. And I know square root of 9 is 3, square root of x squared is x, and I'm left with 2x. All right, when you're dealing with variables, just take however many out you need. If this was cubed root, you just pull an x out, because cubed root would mean you need 3 x's. If you had x to the 4th and this was cubed root, you'd pull 1 out and have 1 left, because you'd say, ooh, I have an x cubed, and this is x to the 4th, this was x to the 4th, I have a cubed, and I'd have 1x left if this was cubed root. Now, this section with that number 36 is included in, you're literally just plugging in. Don't let that get overcomplicated. B squared, they're saying b is 7. Minus 4 times AC. Well, a is 6. C is -5. So I have, we'll go this way. I have the square root of 49, and then I have a negative, and I like to think evens. So 4 times 5 is 20, times 6 is 120. I have a negative and a negative, so plus 120. And now I have the square root of 169, that happens to be 13. Okay, now one more we'll do. Rationalize the denominator. I already explained. You got to think what makes it a perfect cube. So perfect cubes are 8, 27, 64, because 8 is 2 times 2 times 2, 27, 3 times 3 times 3, 64 is 4 times 4 times 4. So we need to make one of these. Well, 4, I can make an 8 out of 4 pretty easily. So what I have to do is take my cube root of 4, and I have to multiply by a cube root of 2. When I do, my numerator doesn't do anything. It just sticks together. 3 times the cube root of 2. But here, I now have the cube root of 4 times 2 is 8. And I know there is a perfect cube of 8, and it's 2. That's how you rationalize the denominator. That took me a little while to get that. So the next section, I'll add a little bit to that, just a quantity that we'll work on. All right, hopefully you enjoyed that. I don't think it's too bad. We'll get to the next section soon.